Hello everyone, my name is Carl Schenzer, and today I will be presenting you a presentation on database analysis. So what is data? Data is facts and statistics collected together for reference or analysis. I think that first we need to learn what data is. You learned what database was last week, which is basically a system for storing and sorting data. And basically all data consists of is binary and programming languages. And binary is a number system with ones and zeros, and it's massive amounts of data that all these programs have to read. And basically programming languages allow for it to be read in a very efficient manner and not have to go through a very tedious computing process. So another way to make sense of data is by visualizing it, making it a visual presentation. We can do this with data mapping, which is common for businesses. What you'll see is all the different data points and data storage and how they relate and their connections to one another. And for a data analyst, this is very useful. This chart right here is very useful. But what people more commonly think of, and it's still data analysis, is charts where they graph a chart, and this can be applied to database analysis as well. However, useful to people with the skills to read these data maps. So the first database analysis program is something called System 360. It was produced by IBM in the late 1960s, and this was the program that the Apollo missions used for their computers. And it basically was a navigational database system which allowed for them to sort through the data very quickly and efficiently. Enough processing and time to understand and process this brand new data with rockets that they were getting, and really created a database analysis program that was unprecedented at the time. Later came SQL, which is a serial query language, and basically this is for relational database, which is sorting data based on relevance and similarities. And then from that, you can group them together and have a keyword to try and find that data, or just address that data as a whole. And then you have SAP, which is the common program for a lot of big business analysis. Real-time database analysis is something that is kind of new. Recently in China, there have been reports that there are many different Bitcoin mining operations. If you don't know what Bitcoin is, it's an anonymous online currency. And it basically consists of all data, and that's what it's becoming. I know that information is essentially data, and so that has always been valuable, but data itself and having that data, and even data itself being used as a currency, is something that we have not seen. And database analysis to that level, the data mining these Bitcoins, they mine 100 coins a day. And they're projecting that these Bitcoins will go up in value for many years to come. Also, what you can do is make data models and trend analysis from these real-time database. Basically allows you to map the trends as they go throughout the day. Anything from as simple as a restaurant, its peak hours, peak customers that it sees, and it'll show you on Google when their business is most busy, all the way to a complicated algorithm for trying to solve or predict rather the stock market and how it's going to react to certain news or events. The Internet of Things, I know I've talked about that a lot. Internet of Things is basically the fact that more and more things are having processors which can connect to the internet. And basically they connect with the server and they're constantly giving data feedback. And what this does is it creates a massive amount of data, almost waves of data. And so it creates the need or the demand for database analysis, something to programs to assess what is going on in the data and essentially make sense of it. And so that's where data analysts come in and data mining operations, because they need to take these massive amounts of data that is constantly being reported and sort through it, give it relevance, see how or what it is saying about what is happening. Real life application. So like I said, there's models and trends that you can try and see. So consumer behavior algorithms, basically it is companies trying to figure out why customers buy things, how they can attract them with advertising, what appeals to them, what their values are, everything and anything in between. And this all comes from data that they collect through surveys, in-store data, what you search online. It can go to a very complex and spotty database analysis program, which is the stock market projection models. And these oftentimes have shown to be not reliable, but sometimes, and they do try to map massive amounts of data. The problem is it's just so unpredictable. It doesn't abide by the logical laws. And then you have a much more logical and standard system with weather models. And this will be like the models when there's a huge snowstorm and they're like telling you how much snow you're going to get. This is based off putting the data that they're getting currently and backing up against a data model, which is a database analysis. And so the future, basically, of database analysis, you're already seeing it. We're living in it, essentially. There's comprehensive traffic systems which will help lights keep traffic flowing with keeping people safe at the same time. Low-risk investing. Many different investing companies are working heavily and investing heavily in database analysis and not analyzing how much data is coming in at one time, when the best points to invest are, when the worst points to invest, when you should buy, when you should sell. And then you have cool things like self-driving cars. And Google is doing this, Uber is doing this, I know Tesla is doing this. The only problem about these cars is they can sometimes, in some cases, be hacked. And that's the only fear, but database analysis is constantly shaping the future. And it basically is the predictor of what the future will be. So database analysis and customer behavior. So like I said, companies will actually buy and try and buy data from companies like Google, because Google, whether you know it or not, whether you're on incognito mode or anything like that, they can still track your search history based on through your accounts, through your network. They can track everything that you do, your searches, and from that they'll sell it to companies, and from that they'll try and suggest you products to buy and shows to watch, services to use, all of that. And that's why many times when you're online, you will see things that you are interested in. It's not because it's just a coincidence. It's because these companies have made an effort to understand consumer behavior and understand the information that Google is giving them, and from that information send you things that you're likely to purchase. And so with all of this, with the database analysis, big problem and concern is privacy. So the question is, how much data is too much data? With Google, the example that I just gave, you never know how far is encroaching on somebody's privacy, and if people are really even consenting to giving all this information with your phone. Apple has all the information that you do on your phone. You could potentially sell it to the government, and they'll be able to predict your behavior, everything. And a lot of people see this as an invasion of privacy, which in a lot of cases it can be. The NSA and the government have recently tried to reach out to Apple, have them teach them how to basically hack the iPhone or hack their security system. And there's actually competitions for hackers, which they try to hack programs and they show loopholes in these programs, and that will allow like government agencies to see more of your information, more of this data, and all of this data is becoming very scary because they're basically able to predict everything that we will do. But at the same time, it is cool because they'll be able to like customize your life. The companies will be pushing the product that you want to see towards you. And so it will be minimal effort, but high reward. But at the same time, the ethics of this are very, very murky. So I think that's all I have for you today. Thank you for tuning in. My name is Carl Schenzer. I hope you have a great day.